So hello and welcome everyone. I am Jay Dalsaniya and in this video we are going to solve the problem of the day, that is gold mine problem. So this problem is comes under the difficulty level medium, and if you do a little bit of brainstorming on how to solve this question, it is not going to be that much difficult for you guys. So I am sitting over here so that you guys can understand the best optimal approach possible for this question. So let's hit the target of 50 likes in this video, and without any delay, let's start the video. So first of all, I will be reading down the problem statement and then we'll be having a look at the examples given in the question. So first of all, what is the question? So given a gold mine called M of n cross m dimension, each field in this mine contains a positive integer, which is the amount of gold in tons. Okay, so each and every cell in the matrix contains some integer that denotes the amount of gold in tons, and initially the miner can start from any row in the first column. Okay, so the restriction of the starting point is that you can start from the first column and any row. You can pick any of the cell in the first column from any row. So from a given cell, the miner can move in three different directions. Okay, so it can move to the cell diagonally up towards the right, so diagonal side, and to the right hand side, and to the cell diagonally downward towards the right. So there are only three different directions from each and every cell. You can move in this direction, and in the rightwards direction. So you have to find out the maximum amount of gold which can be collected until he can no longer move. So you have to find out that like what is the most amount of gold that can be collected by the miner if he starts from any of these cell in the first column. So now what I'll be doing, let's try to understand with the help of the test case which has been mentioned over here, so we can have a better understanding. So here is the entire test case given to us. So what is the test case? So n is equal to 3 and m is equal to 3. So the dimension of the given matrix will be n cross m, and n and m over here, both of them are same. So we can imagine a matrix of size 3 cross 3, and the elements will be 1 3 3 2 1 4 and 0 6 4. These are the values present inside each and every cell. So now we have to find out that what is the maximum amount of gold he can collect if he starts from any of the cell in the first column. So I have three different values, right? I can either start from this 1, I can start from this 2, or I can start from this 0. So one by one, let's try to tackle each and every element in the first column, and let's try to find out that what will be the best amount of gold we can collect from each and every cell. So from 1, I have two different options. But before understanding that how to find out the values, we need to know which different directions we can. So you can move in this direction, you can move in the rightwards direction, and you can move in the downwards rightwards direction. So basically, if a cell is present over here, you can move towards that cell. If a cell is present in the right hand side of this cell, and this is going to be your starting cell, let's say you are currently standing at this cell, you can move in this three different directions. And if there is a cell present over here in the top right hand side, then you can move in that cell as well. So there are three different directions. I hope nothing makes like difficult to understand about direction. So now let's say to find out the values, like let's say from this one I can move in this direction, I can move in this direction, I can move in this direction, right? So what I did, as I know, I have to find out the maximum amount of gold which I can collect. So what I'll be doing, I only have two possible direction. One of the direction goes out of the matrix, so I can either go to this 3 or this one. And as I know, I need to find out maximum one, so what I'll be doing, I'll be choosing the maximum one. So from here, from this one, I'll be traveling to this 3, and again from here I can have two different directions, but basically 2 are valid, and out of 3, so I can move in this 2 direction. And now again I'll be greedy, and I'll be selecting this 4. So now from here I again have three different direction. No, actually I have three different direction, but none of the direction is inside the matrix. So this is the entire way, and in this path, how many cells and which cells were encountered. Let's try to find out the value. So that would be 1 plus 3 plus 4. 1 plus 3 plus 4, that is going to be 7 in this scenario. So now this is one of the possible path, and now let's try to find out, let's say if I am selecting a different path, then what is the value which I'll be getting from 1. So now let's say if I start in this direction, so from this 1 I'll be going to this one, and now from 1 again I have three different possibilities. I can move any of the one. So what I'll be doing, I'll be going with the major one. So that would be with this 4. That would be 1 plus 1 plus 4, that is going to be 5. And I don't think you can do better than this 5 and 7. So for this first cell of the first column, you can do better, means like you can get the maximum answer as 7. So for this one, it will be 7. And now let's try to find out the answer for the other ones. So now let's try to find out the answer for this two. So from this, I can move in 3 different directions, but I'll be moving in the most optimal one. So I'll be selecting this 6. So from this one, from this 2, I will be moving in this direction, and from 6, I can move in 2 different directions. And both of them are having the same value, right? So it does not matter whichever 4 you are selecting. So I'll be moving in this direction. So that would be giving me 2 plus 6 plus 4, and that comes out to be 12. So for this, I got one of the answer, that is 12, and I think you cannot do better than 12 for this 2. So now let's try to understand, let's try to find out the maximum answer for the last cell. Let's try to see. And now for the last one, what do you think? What can be done? So let's say for this 0, I have 3 different directions, but only 2 of them are valid. So I'll be moving in this direction 6, and from 6 I have 2 directions valid, and both of them are having the same value. So that would be 0 plus 6 plus 4, that comes out to be 10. And for this one, I cannot do better than 10. Right? So for each and every cell of the first column, I found different answers. And from this one, what do you think, which is the maximum one? Obviously this 12. So the output for this test case comes out to be 12. Okay, so this is the entire process, and I hope you understood that how to find the answer. And you can check it in the quotient as well, inside the problem statement, that for the example number 1, the output is equal to 12. So the main reason behind showing you each and every step was that in the upcoming part of the video, you will be understanding that what actually is the process, how we can solve this question. Okay, so now let's try to think a little bit, and like let's try to find out what can be the solution of this one. So let's try to find out any of the approach number 1. So now let's say I have a 3 cross 3 size matrix. So what I can do, can I explore each and every possible path and try to find out the maximum answer? Yes, you can do that, but the time complexity of that approach will be very much huge. It will be something exponential or near about to exponential. Okay, so what I'll be doing, if you try to focus on that approach, let's say from this 0, from this cell I'm moving in this direction, and from this I'm moving in this direction. So now let's say if you took a different path, and if you were traveling from this cell, you started from this cell, this one. So from this one, what you can do, you can move in this direction. So again, you will be encountering this cell for which the maximum path you might have already explored. And from here, you might be again going in this direction. So you are following the same path again and again. And the time complexity of this will be near about exponential, and this is not the feasible approach. Okay, and if you try to follow this approach, the brute force, that is trying out each and every possibility, your approach is going to fail for sure. So now what can be the optimal approach? What can you do in order to avoid the repetition of the paths? So the repetition of the paths can be avoided with the help of memoization. So basically, if you focus on what the question is trying to say, the question is trying to say that you have to find out the maximum amount of gold which he can collect, right? Basically, you have to find out the maximum sum of the numbers in that path. So now, if you focus on that, no, as I mentioned that there are 2 different ways to follow a different path. One of the path is this one, and this path can be followed by someone in this manner as well, right? So if you have already understood what I'm trying to say, let's say for any of the cell, inside the matrix, if you have found out that what can be the maximum amount of gold that can be collected starting from that cell, then you can store that value in some table in some different matrix, and that matrix can be called the memoized matrix. Basically, you will be taking the help of the other matrix. So let me show you. Let me just copy the entire test case, that is 133, 214 and 064. 133, 214 and 064. Okay, so now for this matrix, what I will be doing, I will not be exploring each and every path. I will be simply exploring each and every cell only once, so that I don't do repeated work. I don't explore the repeated path. So now let's try to understand what I'm trying to say. Let's say this is the matrix, and this matrix goes by the name DP. Basically, for each and every cell, I'll be storing that from this cell, what is the maximum amount of gold that you can find, right? So that values will be stored and initialized this entire DP matrix with -1. So -1, that indicates that this path, that this cell has not been explored yet. So now let's try to focus more on what I'm doing. Each and every steps are very much important. So you will be understanding, and it is possible that after understanding the entire approach, you guys might be able to write down the entire approach on your own, just looking at these steps. Okay, so pay proper attention right now. So now let's say if I'm starting with the cell number 1 from this cell. So from this cell, I have two different possible paths. I can go in this rightwards direction, or I can go in downwards right direction. Right, so I have two different paths, right? So for each and every cell, I have, let's say, three different possibilities. I can go in upper, that is upper right direction, in the right direction, or I can go in the lower right direction. Three different values will be possible for each and every cell. So basically, what is the maximum amount of gold that any of the cell can carry? Gold that any of the cell can get carry is nothing but the maximum of the value which you have found from the upper right hand side, and the lower right hand side. Okay, are you guys able to understand this formula? That basically, what is the maximum amount of gold that I can get from all these three different cells where I can travel? And I'll take that maximum and just add whatever gold is present at the current cell. Okay, so now I will be exploring each and every side. I will be going in the upper right, rightward direction, and lower right. Okay, so three different function calls will be made. A DFS function, a DFS call is required. I'll be using DFS, depth first search, in order to traverse the entire matrix. Obviously, there are three different ways, like only two different ways to travel the graph or something, right? So basically BFS or DFS. And here DFS is more suitable because you don't need to work radially. If you are supposed to work radially, then that means you can use breadth first search. But here you need to focus on a particular path. So that's the reason I'm using DFS. Now I'll be applying DFS from each and every cell of the first column. And let's say I made a function call to the first cell of the first column. And now I have two different paths. That is row right hand side and lower right are the valid path. And I cannot move in this direction, upper right hand direction. So I'll make a function call to both of them. So in the rightward direction, if I move in this rightwards direction, I'll be getting 3. So from 3, where can I move? I can move in the rightwards direction. I can move in the lower right. So I have this 3 and 4. So basically, I'll explore both of them. I'll explore 3 and 4. So let's say if I move to this 3, I know that after 3, I cannot move anywhere else. So what is the amount of gold that you can collect from this last 3? That is equivalent to 3. So I'll add and pass that value to this 3 over this function call over here, right? So from this 3 we got 3, and now from this 4 I will be again calling to this, making a function call to this 4, and from this 4 I'll check whether I can move forward or not. So from 4 as well I cannot move anywhere else. So this 4 will also return the value that from this cell you cannot move forward, and currently my position has 4 tons of gold. So 4 will return 4, and you'll be getting two different answers at this function call. You will be getting 3 and 4, right? So basically you got two different answers, that is from the rightward cell and from the downwards right cell. 3 and 4, choose the maximum one. Which is maximum between 3 and 4? Which is maximum between this and this? I can say obviously 4. So for this cell, you have to just select the maximum that you got from the right and the lower right. So I got 4, maximum of 3 and 4, that is right and lower right. 3 and 4 came out to be 4. So adding 4 to the whatever amount of gold is present at that cell. So I can see 3 tons of gold is already present. So that becomes 7. So whenever the entire thing, that exploration of all the different paths is completed, so you will be finding out the maximum gold that you can collect from that XYZ cell. So from this cell, you can collect 7 tons of gold. So make an entry inside the DP area that from this cell maximum 7 tons of gold can be collected. Okay, so -1 will be replaced by 7. Similarly, I have also completed the answer for these two cells, right? I got the answer as 3 and 4. So I'll make an updation over here. That is, this is 3 and 4. This is the maximum gold you can get from that cell. Okay, so basically what is the use case? What is the use case about this? You will be understanding just in a few minutes. So now let me just clear out this drawing a little bit. Okay, so now we have explored this path. We have explored this direction, the rightwards direction of 1. So now let's try to explore the other direction, that is in the lower right. So in the lower right, this is the cell, that is 1 is the cell number. So now from this one, before exploring or making DFS further call, you will be checking inside the DP matrix whether that cell value is -1 or it is not -1. If it is -1, then that means that cell needs to be explored again. Like basically the exploration is not done at least once, so you'll be exploring that cell as well. So now I can see -1, so I'll be exploring all the paths, so I can move in the upwards direction, downwards, and the rightwards direction. So 3 different directions are possible for this one, right? All the 3 different directions are possible. Let's say if I move in the upright direction, from 1 in the upright direction, I can see 3. So I'll be reaching over here. So as soon as I reach this 3, I will be checking whether I have already found the answer for this 3 for this cell or not. So I'll be checking the DP array and I can see it is not -1. So if it is not -1, then that means I have already explored the further paths passing through this 3. So I'll just fetch the value from the DP array. So from this DP array, I will be getting 3 for this upright direction. That is upright direction. Now from 1, I'll be moving in the rightwards direction. Okay, so I will not make further DFS call for this 3. So now I'll be backtracking again and I'll be exploring the rightwards direction from 1. So from 1, this is the rightwards direction. Again, I'll be checking inside the DP array whether the value for this cell is -1 or not. It is not -1, it is 4. So from DP array, I will fetch that value. So this 4 will return what? It will return 4 in this scenario. That 4 is the maximum amount of gold that can be collected from that XYZ cell. Now from this one, only one direction is left to explore, and this is the direction. So I'll explore this direction because I can see -1 is present, right? So this is 4 and this is the lower right direction, and I cannot see anywhere else I can move from this 4. So for this 4, exploration is not possible in any of the direction. So I'll update that value that for this 4, only 4 is the amount of gold that can be collected. And now this 4 will return 4 to this one. Okay, so now I got 3 different values, and what will be the maximum one? So for this one, I got maximum of upper right, rightwards, and lower right. So for lower right, I got 4, for the rightwards direction 4, and for the upper right, I got 3. What is the maximum one? 4 is the maximum one. And what is the current gold that cell is holding? It is holding 1. So what is the total maximum gold that you can collect from that cell? It is 5. So inside DP matrix, just update that value. I'll update it to 5. So now you can observe, you might be able to observe that whenever you again come to the cell number 1 in further DFS call, you will not explore all the paths because you have already found the maximum answer, and you will just fetch that value which you have stored inside the DP array. And this will reduce a lot of tasks. It will reduce the entire time complexity because here you will be exploring each and every cell only once. None of the cell will be recalculated any of the time. They will be calculated only once. So the overall time complexity becomes total number of cells inside the matrix. So what is the number of cells present? N cross M. So the overall time complexity of this approach comes out to the order of N cross M. And what about the space complexity? The space complexity depends upon the DP array, and DP array takes order of N into M size. So this is the space and this is the time complexity, right? So this question was not that difficult. Few of the concept memorization plus DFS is sufficient, and it is sufficient to get the solution accepted. Right. So now let's have a look at the implementation part of this algorithm, and let's solve this question. So this is the implementation part of this question, and I have implemented this entire thing in Java, but the same can be implemented in other languages. Just take the reference of what I have explained few minutes back. So now let's start. This is the max gold method, and we have to write down our logic inside this method. N and M are the dimensions of the matrix, and I have changed the name of the matrix given to us. 2D array, I have changed it to matrix. So I have created a new DP array that will be helpful for my memorization process, and I have initialized the entire DP array with -1 because I need to make sure whether that value or the cell is visited or not. So -1 is a good indicator in this scenario. Right? And now I have used one more variable that will store my answer. Something is required to store the answer, no? Right? And I know -1 is not going to be the answer because I'll be getting positive values, and how positive values you can observe inside the constraint that each and every cell will be having positive values. So I initialized it to -1. Now I have started an iteration over each and every cell of the first column one by one. and I'm making a DFS call. You can observe I comma 0, basically column number 0, ith row, making a DFS call. And whatever is the value, maximum value for that cell, whatever is the maximum amount of gold I can collect for that cell, I'm storing it inside temporary variable, and I'm just comparing it with the overall answer and what can be the maximum answer, right? So now let's have a look at the DFS, a basic DFS function call. Okay, so what are the arguments? So argument is the matrix. We require the matrix, the current cell number I comma j, and the DP array in order to just check the memoization. So now I have just fetched the n cross m, basically the dimension of the matrix, and I have used a temporary variable. You will understand why I have used temporary variable. So now what I'll be doing, so I have three different directions, right? You agree? So top right diagonal, and basically like right side and bottom right diagonal, right? So three different directions are possible. So I'm checking I minus 1 and j plus 1. So the dimension, if I'm currently standing at I comma j, let me just show you what is the position. So now let's say currently you are standing at I comma j, and I comma j, this is your I comma j. Now what is the, how to reach this cell? So basically if you subtract the value of row by 1, because you know the row number is being reduced, and if you increase the value of column number, you know the column has been increased by 1, so you'll be reaching this one. So that is I minus 1 and j plus 1. You need to verify whether the value of I minus 1 and j plus 1 remains inside the matrix or not, right? So now let's say to find out, if I move in the rightwards direction, you know the row number remains as it is and the column number is increased by 1. Similarly for this one, what will be the scenario? I know that row has been increased by 1, and similarly the column has increased by 1, so that would be j plus 1. So these are the three different directions in which I can move. Now let's get back to the coding part, and now you will be able to understand what is this I minus 1 and j plus 1. Okay, so I need to check whether the value remains in the matrix or not. Okay, and I'll be checking if the cell has been already found. Basically, if it has been already explored, then value will be minus 1 inside the DP matrix, and then I'll be just comparing the value of that cell with the temporary variable. I need the maximum from upper right, lower right, and the rightwards. Okay, so this will be compared, and now I'm just checking the right hand side. Okay, so for right hand side, I know just there will be increase in the column number only. So now j plus 1 will be checked, and if that cell is already explored, so just fetch the value and compare it with the temporary variable. Else I'll be making a function call, and I'll be just comparing the value of temp with the value written by the DFS call. Okay, so now the same thing will be done with the bottom right, and at the end, whatever is the value of the temp, I'll be just adding the current matrix, that is basically I comma jth cell value with the temporary variable, and that will be updated inside my dpi comma j, and I'll be returning dpi comma j. Right? So this is the entire DFS with some memoization, and now let's try to just completely submit this code and let's see the acceptance. And we can see that the problem has been successfully submitted. And as I mentioned, the time and space complexity remains order of n into m, and this is justifying the expected time and space complexity, right? So this was all about the gold mine problem, a basic memoization with some graph concept like DFS with matrices, right? So that was it for in this video. I hope you really enjoyed this video, and if you really enjoyed this solution, do hit the like button and comment down your solution in the comment section below. So thank you for watching, and I will be seeing you in the next video. Till then, bye bye.